Hi, this video will talk about the introduction of data structures in algorithms. These are our objectives that at the end of the lesson, students will be able to learn data structural algorithms, understand the characteristics of data structures, and learn some important categories of algorithms. Now, data structures are programmatic way of storing data so that data can be used efficiently. Almost every enterprise application uses various types of data structures in one way or another. So, this video will give you the great understanding on data structures needed to understand the complexity of enterprise level applications and need of algorithms and data structures. Now, why do we need to learn data structures and algorithms? As applications are getting complex and data rich, there are three common problems that applications face nowadays. We have data search, like if you are going to consider an inventory of 1 million, like 10 to the 6th items of a store. If the application is to search an item, it has to search an item in 1 million items every time, slowing down the search. As data grows, search will become slower. Now, another common problem is the processor speed. Although being high processor speed falls, it will fall limited on the data grows to million records or billion even. Another one is the multiple requests. As thousands of users can search data simultaneously on a web server, even the fast server fails when searching the data because of multiple requests. So, to solve the above mentioned problems, data structures come to rescue. Data can be organized in a data structure in such a way that all items may not be required to be searched, and the required data can be searched almost instantly. Now, what are some of the applications of data structures in algorithm? First, what is an algorithm? So it is a step-by-step procedure which defines a set of instructions to be executed in a certain order to get the desired output. Algorithms are generally created independent of underlying languages. Say, for example, an algorithm can be implemented in more than one programming language. From the data structure point of view, these are some of the following categories of algorithms. We have like search algorithm, sort algorithm, insert, update, and delete. For search, like an algorithm to search an item on a data structure. For sort, like what's an algorithm to sort items in a certain order, whether ascending or descending. Next is insert. Okay, insertion algorithm to insert an item in a data structure. Another one is update, like an algorithm to update an existing item in a data structure. So somewhat like editing. Next is the delete. Okay, this is an algorithm to delete an existing item from a data structure. Now, some of the following computer problems that can be solved using data structures, like the Fibonacci number series, the knapsack problem, the Tower of Hanoi, all pair shortest path, or the shortest path by Dijkstra, and project scheduling. Um, Maybe you are familiar with some of the computer problems, and probably you have solved any of the following. All right. Now let's go to the overview. Data structure is a systematic way, it is said, to organize data in order to use it efficiently. Now, for the following terms are the foundation terms of a data structure. So we have interface and implementation. Interface, like each data structure has an interface, okay, in which this represents the set of operations that a data structure supports. An interface only provides the list of supported operations, a type of parameters they can accept, and return type of these operations. Another one is the implementation term, which provides the internal representation of data structure. Implementation provides the definition of algorithms used in the operations of the data structure. Now, what are the characteristics of data structure? We have the correctness, time complexity, and space complexity. Correctness, okay, the correctness characteristic of data structure is the implementation should implement its interface correctly. Okay, implementation, the correctness of the implementation of the data structure. Next is the time complexity. So this refers to the running time of the execution or the execution time of operations of the data structure. Okay. So for the time complexity, we must have to consider the running time that is as small as possible. Now for the space complexity, this is the memory usage of a data structure operation should be as little as possible. So like little memory space to be used for the data structure operation. Now, the need for data structure, like as mentioned before or in the earlier slide, for the common problems for searching, the processor speed, and the multiple requests, so we must have to consider. Next, we have here the execution time cases. So there are three cases which are usually used to compare various data structures execution time in a relative manner. We have the worst case, the average case, and the best case. For the worst case, so this is the scenario where a particular data structure operation takes the maximum time. Then, if an operation's worst case time is f of n, so this operation will take more than f of n time, where the f of n represents the function of n. The average case is, this is the scenario depicting the average execution time of an operation of data structure. If an operation takes f of n time in execution, then m operations will take m of f of n time. Now we have here the best case. So this is the scenario wherein the least possible execution time of an operation of a data structure. So if an operation takes like f of n in execution, then the actual operation may take time as the random number, which would be the maximum as f of n. So there are the these are the basic terminologies of data structures. We have data, data item, group items, elementary items, attribute and entity, entity set, field, record, file. Okay. And most of these terms are somehow familiar to you. Okay. Like what is a data? So these are values or set of values. Data item, those are data item that refers to the single unit of the values, single unit. Group items, okay, these are group items that are divided into sub-items. Elementary, those are data items that cannot be divided into sub-items. Attribute and entity, this is very familiar to you. Attribute an entity that which contains certain attributes or the properties which may be assigned values. All right. Okay, this can be found in OOP. Then the entity set, these are entities that similar attributes form an entity set. Field, okay, it is a single elementary unit of information representing an attribute of an entity. Record, it's a row, it's a collection of field values of a given entity. File, it's a collection of records. Okay, so that would be all for the introduction of data structures. So next video will show you on the basics algorithms or the algorithm basics of data structures. Okay, thank you.